Hi, today we're going to be talking about how to solve two-step equations. So what does it mean to solve an equation? So if we have an equation 2x plus 4 equals 16, what they're asking us to do when we're solving an equation is to figure out what x has to be, what's the value x has to be in order to make both sides equal. And we do that by isolating or getting the variable by itself. The way that we get the variable by itself or solve an equation is by undoing the operations using inverse or opposite operations. So let's take a look at this first problem. First step is always going to be to decide what operations are actually being done. So when I look at my problem, I have 2 and the 2 is multiplying the x. I know that because it's a coefficient. It's directly next to it. There's no sign underneath. So I know that this is 2 and it's times x. We're multiplying 2 times x. Sometimes it helps to draw that in. Then on the other side of that, we have a 4. And the 4 is being added. So we're adding 4. Remember that the sign always belongs to the number that's following it. So this is plus 4. Once we've identified what our operations are, we're going to use inverse operations and work our way backwards using PEMDAS. So normally we'd solve using order of operations and we'd start with grouping and working our way down. However, in an equation, since we're trying to undo, reverse, or do the inverse, since we're undoing, we're starting at the bottom and working our way up. That means that we have to start with any addition or subtraction. So I'm going to start by undoing this plus 4. It's also always a really good idea to draw a line through your equation so you can easily recognize the left and right sides. So the opposite of plus 4 is minus 4. So we subtract 4. And if I do it to one side, I have to do it on both sides in order to keep it balanced. The plus 4 and minus 4 make 0. So now, when I simplify, all that's left on this side is 2x, or 2 times x, and that would be plus 0, which we don't write, is equal to 16 minus 4, which is 12. Outstanding. So now we've done our first step of our inverse PEMDAS, or reverse order of operations. Next, we're going to undo, or use the inverse, to get rid of any multiplication or division. In this case, we have 2 times x. We're going to get rid of that by doing the opposite or inverse of division. You'll notice that we're using a fraction bar. It's a little bit easier to write this way, and it keeps your notebook a little cleaner. Okay? So 2 divided by 2 cancels out. It makes 1x. So when we simplify on this side, we get x. And when we simplify on this side, 12 divided by 2 is 6. Great. So now we figured out what the value is for 6. But how do we know if the value is for x? How do we know if we're right? You can plug it back in. So we can evaluate where x used to be 2 times x. I'm going to use our answer, or our value of 6, to see if that works. So if x is actually equal to 6, then when I multiply it by 2 and add 4, it should equal 16. 2 times 6 is 12, plus 4 is 16. So it looks like our answer is correct. Let's check out another one. So here you can try this one on your own, and then we'll go over it together. So hopefully you started by drawing a line through your equation and figuring out what your operations were. Okay, so it looks like we have 2 operations. We have a minus 7, and we have a x divided by 5. Inverse order of operations tells us that we need to begin with our addition subtraction. So we'll do that first. Canceling out the minus 7 would be plus 7. Inverse of subtraction is addition. that's going to cancel this out and get us one step closer to isolating our variable. So now when we simplify, all that's left on this side of the equation is x divided by 5, which is equal to 3 plus 7, which is 10. After this, we're going to get rid of any multiplication or division that remains, such as our divided by 5. Opposite of division is multiplication. Make sure that you're using a dot here, times 5, instead of an x, because you don't want to have it look like another variable. So times 5 cancels out our division, and when we simplify, all that's left on this side is x is equal to 50. Hopefully you've solved that by plugging it back in, which would give us 50 divided by 5 minus 7 should be equal to 3. 50 divided by 5 is 10, and 10 minus 7 is in fact 3. Now let's check out let's try a more challenging example. So you may have noticed that for this problem, the value of x is on the other side. So instead of solving on the left side like we did before, the x is on the right. So that's the side where we need to get the variable alone by working on it. And we have a negative 4 being multiplied by x. Remember, this minus sign has to go with the number in front of it. And we have a plus 9. We get rid of the plus 9 first. Subtract 9 from both sides. And when we simplify, that gives us negative 4x, which is left. Remember, the negative has to stay with that. 13 minus 9 is 4. Now, we do the opposite of multiplication. You might be tempted here to try to add 4, but the 4 isn't being subtracted to x. This is the same as saying negative 4 times x. So to get rid of the multiplication, we divide by the exact same value. Divide by negative 4. So now, when we simplify, negative 4 divided by negative 4 is negative 1 is equal to x, or x is equal to negative 1. You can go ahead and try this problem on your own. So the challenging part about this problem is that you might be a little confused about what to do with this 10 and how to handle this. So here is a minus 10, and we're then multiplying x times a negative 5. Okay, remember, sign goes with the number right behind it. So even though this is a negative 10, you can think of it as subtracting 10, because doing the negative is still the opposite, or subtracting, taking away. So to do the inverse of that, we would add 10 to both sides, which cancels out, leaving us with negative 5 times x, or negative 5x, equals 20. Now remember, even though this might look like minus 5, we're actually multiplying by negative 5. So to cancel that out, we need to divide by negative 5 on both sides. And then we may simplify and get that x is equal to negative 4. This is the same when we're looking at a problem where there's a negative sign in front of the division. Here we have an 8, and if it doesn't have a sign in front, we assume it's a plus or positive. And then we have division, x divided by a minus. A minus sign goes with the 5. So when you're trying to get rid of division and there's a minus sign in front, assume that it's going with the denominator. So when we solve this, we need to get rid of this positive 8. Remember, we're not subtracting 8. The 8 is a positive value. So to get rid of that, you do the inverse of plus 8, which is minus 8 on both sides. And then when we simplify, we're still left, we still have this whole thing, minus x divided by 5. And then denominator. And that's going to be equal to 11 minus 8, which is 3. So now the opposite of division is multiplication. But since we're dividing by what is essentially a negative 5, we need to multiply by a negative 5 times negative 5 on both sides, okay? Which means that when we cancel this out, the negative is canceled, and we're left with x is equal to negative 15. So, a quick review of what we've learned about two-step equations. First of all, we solve for x by finding the variable. We find the variable by isolating the variable using inverse operations. And when we're solving an equation, we want to use opposite order of operations because we're using the inverse. We're doing the opposite, so we're undoing. Since we're undoing, we're going to use opposite order of operations, meaning we get rid of any addition or subtraction, followed by getting rid of any multiplication or division. I look forward to talking to you more about two-step equations. Have a great day.